Good evening and welcome to your second Chapter 7 video. Tonight we will work backwards from what we did in Video 7.1. We are going to write the formulas this time. So grab a hot cocoa, warm blanket, your pink sheet, and let's begin. So we are going to begin by writing binary ionic compounds. If we remember, a binary compound is composed of only two different elements. So binary meaning two. The number of positive charges must equal our number of negative charges. So remember, when we're building these compounds, we're looking at ionic compounds. So we're going to take a positive cation and a negative anion, and we are going to combine them. When we combine them, we want to make sure that the charges are equal, because our compounds are always neutral. We are always going to list the symbol of the cation first. So, for example, if we were to take Mg plus 2, so magnesium, again, look it up on your pink sheet, you can see it usually comes with a positive 2 charge, and bromine, which is a negative 1, and again, you can look it up, and its most common is a negative 1, and we combine them, we are going to get MgBr2. You'll see that once we make the compound, the charges are no longer shown because it is neutral. Now, those ones that you saw that had a negative charge, those are a special type of ion. So those are your polyatomic ions. So they are going to be put into our formulas, and when we put them back into our formulas, their charges will equal out with the cation or the anion, and then they will be neutral. So the easiest way to do this, to make things neutral, is using the Criss-Cross method. In the Criss-Cross method, charges are going to be dropped to the subscripts of the opposite ion. And now when we take those charges and we drop them, we also drop the charge, the positive or the negative. So it just becomes a regular subscript on the bottom, no charge included. And then once we have it written, we're always going to reduce it to the lowest terms. So again, let's look at some examples. If I have Al plus 3 and O2 minus, and I crisscross them, I took my positive 3 and I brought it down to the bottom. I took my negative 2 and I crisscrossed it down to the bottom of Al. So I have Al2, O3, you can see there are no longer any charges associated with those subscripts. In the next example here, you can see we reduced. So I had a positive 2 and a negative 2. I crisscrossed them, so 2 came down, 2 came down. So I had Zn2, S2. Well, then I get ZNS. So I can cancel these two lowest terms. Now, if there's one of things, we usually don't write the 1, so that's why we don't see it ZN1, S1. If you write the symbol, it's going to be assumed that you have to have at least 1, so we don't write the 1s, we write anything higher. So here's where we take those polyatomic ions, those molecules that had that negative charge. Usually we can recognize them, because remember, you're going to be working with names now and not the formulas. So we can recognize them by an ending of "ite" or "ate" instead of "ide." Usually anything that ends in "ide" is just a regular element. So it's on the actual periodic table. "Ite" or "ate" means you have a polyatomic ion. So let's write formulas, or if we're writing formulas with polyatomic ions. So your charges are still going to be equal, and our cation is still going to be listed first. So usually this is the other element, but we do have two polyatomic ions that are cations. Now, when we start crisscrossing, we may need more than one polyatomic ion. So what we're going to do is we're going to put the polyatomic ion in parentheses. And the reason we do that is because we don't want our subscript to go to just the last element. Or maybe our element ends, or our polyatomic ion ends in a number. Well, we can't just add a number after the number because that changes how many we have. So we'll often put the polyatomic ion in parentheses. So, for example, we have Ag and we have NO3. Well, Ag is 1 because it's not written, and it's going to fall to the bottom over here. NO3 is going to fall to the bottom over here. So in this case, since they're a 1-to-1, I don't really need parentheses. However, if I had Al3+, now my 3 comes down, and 2 minus, that's going to come down. So I have Al2SO4. I have to put that in parentheses. If I don't, I'm going to get something that looks like Al2SO43. Well, that's a completely different molecule. I don't think that molecule can even exist. Someone may prove me wrong someday, but right now that doesn't exist. So we need to make sure that we have SO4 in parentheses to say we have 3 O's or O4s and 3 S's. So this goes to both of those. So that whole compound we need 3 of. So let's do some practice. So if we have potassium iodide, you will definitely need your periodic table unless you have memorized these, which some of them you may have since you have a quiz coming up. So we have potassium iodide. So what is potassium? Well, potassium is K. So I've got K, and K comes as a positive 1 charge. Then I have iodide. So how do I know which side to look at? Well, my ending is IDE, so it's going to be just the element. So I have I, and I comes as a -1. So I'm going to crisscross my charges down so that I get Ki. Next one, sodium hypochlorite. So we'll start with the cation. Cation is sodium. Sodium is Na, and it comes with a positive charge. Hypochlorite, well, that's got that ite in there, so we're going to look at the side with our polyatomic ions. So we're going to look up hypochlorite, and it is ClO minus. So ClO minus. And we're going to crisscross our charges. Now, do I need to put ClO in parentheses? Not in this case, because I only have one of them. So I can just say NaClO. Iron 3 sulfite. Now, if you remember back from the last video, this 3 means that iron has a positive 3 charge. If I looked up iron, iron would have all those charges, so we need to know which one we're using. So iron in this case is going to be iron plus 3. Now we have sulfate, ends in ATE, so again it's a polyatomic ion. So when I look up sulfate, I get SO4 minus 2. So I'm going to crisscross. I'm going to take my 3 and bring it down, my 2 and bring it down. So now, since I have to bring a 3 after a 4, I need to make sure I put SO4 in parentheses. So I'm going to have Fe2, open your parentheses, SO4, close your parentheses, and put the 3 on the outside. Calcium carbonate. Calcium, Ca, it carries a positive 2 charge. Carbon 8, again it's an 8, so it is on our polyatomic ion sheet. So CO3 minus 2. So we're going to crisscross our charges, and they're going to come down, and I'm going to get CaCO3. Now you say, I had 2. Where did the 2's go? Well, remember we're going to simplify to lowest terms. So I know if I'm going to bring this 2 down and that 2 down, they're both going to be 2's. So I can just simplify them to positive 1 and negative 1. Simplify them to begin with so that when I bring it down, I know I'm going to be in lowest terms. And again, since I'm a 1-to-1, I don't need to worry about the parentheses. And then cobalt to fluoride. So I've got CO. Cobalt is going to be positive 2 charge because it's telling me I have a positive 2 charge. So again, this tells the charge of the cation. Remember, not the anion. It tells the charge of the first one. And then I have fluoride, again ending IDE, so I know it's just the element fluorine. And F has a negative 1 charge, so crisscrossing my elements. So this becomes COF2. So what if we're working with those molecular formulas? So these are the ones with the prefixes. In these, I don't need to look up any charges. So I just need to know what the prefix is. So the prefix tells me the subscript. So these should be pretty easy to do as long as you have remembered your prefixes. So let's try them. Carbon. Carbon is C. Tetra, bromide. So I have tetra. Tetra means 4. Bromide means I have bromine, because remember we always changed the ending to IDE. So this would be CBr4. Tetra, phosphorus. So here's tetra, again phosphorus. So phosphorus being P, tetra 4. Decoxide. So deca is 10. Oxide, again just the ending had been changed from oxygen. So this would be P4O10. Di, arsenic. So arsenic, AS. Remember, it's not AR. A lot of you are going to make that mistake. Arsenic is AS. AR is argon. So AS for di is 2. So diarsenic, trisulfide. So sulfide sounds a lot like sulfur. Tri is 3. Selenium has no prefix, so it's just Se. Hexafluoride. Hexa meaning 6, so SeF6. And finally, antimony pentabromide. Antimony is a funny one that doesn't seem to go with anything. At least the symbol doesn't seem to go with the name. So it's one of those silly ones to try to remember. So antimony, SB. Penta, meaning 5. Bromide, so SBBr5. And that is how you name molecular compounds. So if you start to see these prefixes, then you know you have the molecular, and we don't reduce when we do molecular compounds. There's no reducing. We just write the subscript that goes along with the prefix. There's no crisscrossing, anything. It's just a straightforward write it down.